Hi guys, welcome to my YouTube channel where we all had chain. So basically we just crack it and escape the matrix. So today it's about a fluid mechanics problem. It's from Pathfinder. It's Pathfinder Check Your Understanding, number 13. So it's a very interesting question. So let me first read the question. A uniform wooden rod of mass m and length L floating in calm water of a tank is being slowly pulled out of water with the help of a light cord attached to one end of the rod. The cord is always kept vertical. So basically this cord is always kept vertical. Water is so deep that the rod never touches the bottom of the tank. So relative density of the wood is it's given the specific gravity or relative density 3 by 4. Deduce the expression for tensile force T in the cord as a function of height h of the end of the rod being pulled above the water level. Acceleration of free fall is g. So basically, suppose here is the T and this is the water level, then this height is h given us. So we have to find tension as the function of h. So let me first analyze the question. Let me first just draw an image for the question. I have already solved it, so I will just explain on it. So after solving after solving this part, so I will ask you. Then I'm telling you already that this image is actually false. This image is actually mistaken. So you have to tell in the comment section what is wrong about this image. I'll tell at the last, but try to uh, answer that after a certain part. I'll tell when you have to answer that. So let me just start by, as it is, let me just start solving the question. So it's given here that we have to, he's being slowly pulled. So we can say that the center of mass has no velocity and no angular velocity. So we just basically do what the velocity. So as the velocity is zero, so we cannot have any acceleration too, because if it is having any acceleration, then it is eventually have some velocity. So it cannot have any velocity. So that we have to consider that it is in both translational and rotational equilibrium. Now, how we solve the equilibrium problem? So we just balance the torque and balance the forces. So here, this is tension T at this point, the point where the string is connected. This is the center of mass, and this is the center of buoyancy. So this is the center of buoyant force where the buoyant force is working. So let me just first write the translational equilibrium. This translational equilibrium के लिए जो I mean the equation for the translational equilibrium. So this upward force is tension and this is buoyant force. Okay. So tension, I can say tension is equal to the exact difference of the buoyant force and the weight. So mg minus. Now how we calculate the buoyant force? This is also an interesting part. So, if suppose this is buoyant force. Now, what is buoyant force? Buoyant force is rho liquid into V submerged into G, right? So, V submerged. How we will find V submerged? So, let me just tell you that if this is H, this height is what? This height is H by sine theta. So, this height, this length is H by sine theta. So, this length is equal to L minus H by sine theta, right? So this is the length. Now it total have a m value, right? So total the mass is m. So mass per unit length would be m by l. So this what we get. This is the mass submerged in the liquid. This is the total mass submerged in the liquid. Now to get the volume, we just divide it by the density of the wood and multiply it by the density of the water into G. And this is given to us. This is 1 by gamma. As you can see, this relative density is given as gamma is equal to 3 by 4. So it is 1 by gamma. Okay. So we have deduced that. So I don't think you have a problem with that. Now comes the rotational equilibrium part. So we can conserve the torque about the center, about this, about any arbitrary points. But our point is not to prove something, right? Our point is to solve the problem. So I will eventually I will choose a certain point where from where my calculation will be easier. Like if I choose about center of mass, what will I get in the equation? I will get T and buoyant force. T is unknown and bind force is unknown because sine theta is unknown. H is also unknown. If we take sense from bind force, then it's mg and t. T is unknown. Now, I mean, it can also be done, but I have taken specifically this because about this point, I will directly get this term L minus H by sine theta. So what we'll do? It will do we'll just balance the talk about this point because we will directly get this value, and if we get this value, I'll directly be able to write t as a function of this. So let me just do it. So this is so let me just balance the thought. This is mg into mg. It's working at L by 2 sine theta. This sorry for the disturbance. So let me just resume the thing. So we are about to balance the torque. Now, if we balance the torque, there is the mg working. So mg is working at, if this is theta, this is L by 2 cos theta. So mg is working at L by 2 cos theta. Mg into L by 2 cos theta. Now, if this length is this, what is this length? This length is L minus, this part is L minus h by sine theta. This length is L minus h by sine theta. So this particular length would be L minus h by sine theta by 2, as the bind force will be working at the exact midpoint of the length submerged. So we'll balance the torque mg into L by 2 cos theta. So it's here is given. So okay, so a mistake. It is mg into L. Sorry, mg into L by 2 cos theta, and it will be bind force. I have written Fp into that length, that is from this point. This length would be, this length is L, and this length is L minus h by sine theta, and this length is L minus h by sine theta by 2. So this particular length would be L minus, within bracket, L minus h by sine theta by 2. What I have written exactly that into cos theta. Okay, I have written here mistakenly also. So this is cos theta, of course. So we just the cos theta gets cancelled in the both sides. Now this is just mgl into is equal to fp into L plus h by sine theta. Now we have already deduced what is fp. We have found this here, that what is fp, that is L minus h by sine theta into m by n into 1 minus 1 by gamma into g. So we just put that value here and we get L square minus h square by sine square theta is equal to L square gamma, and we get L square into 1 minus gamma is equal to h square by sine square theta. So from here we just directly put the value, replace the value of h by sine theta in the first equation, and we just uh, sorry and sorry just wait for 6 seconds. And if this is L into this h by sine theta, if we put there, we get this value. Now, so I was about to tell the question. So here's a question now. What may be the question? We have already found this. But if you see the Pathfinder solution or the answer, it is given us three different answers. I mean, one is given for h where 0 to L by 2. One is given h L by 2 to L, and one is given h greater than L. So why these three different answers are different? I mean, we have taken sine theta as general. Then why should I have to consider these three cases? This is a very important question. This is a very important point of this question, and I hope you will figure it out by just looking at this relation. Just look at this relation, give it a thought that why these different cases are given. Just give it 5 minutes, and or you can continue. I am just continuing in the video, or you can give 5 minutes to think of this, and from this discussion, you can also tell why is this image. This image I am showing you again the image. Why is this image false? Why is this image mistaken in the previous case? Why is this mistaken? Okay, so you think, and after pause the video, think, and then come back to the video. I am continuing. So the matter is that here is given as h square by sine square theta is equal to L square into 1 minus gamma. But can you see the relative density here? It is 3 by 4. So h square by sine square theta is a positive value. It's a positive value. So this has to be positive. So how can this be positive? 1 minus gamma is positive, and its minimum and its maximum value is just, I'm sorry, just 1 minus gamma is only valid up to the point, where it is L by 2 actually. Because this means you can just see that this h by sine theta remains constant throughout the point, throughout the thing, right? So h by sine theta means the submerged length. So I just do it in the next image. So this is the submerged length. This is h by sine theta. That means this length is constant throughout the thing, throughout the process. But why? So does that mean that this is just rotating about this point? The answer is yes. This is rotating about this point up to. You will probably think that this is rising, so this length must change, but this is not. That's the beauty of this problem. This length is not changing with time because we get h by sine theta as a fixed value n square into 1 minus gamma. And what is this value? This is equal to L by 2, L square by 4. That means h by sine theta is equal to L by 2. That means this length is L by 2. Right. But think of this when this h is equal to L by 2. What happens then? When it becomes h by 2, just think of that. This is rotating, this is rotating, this is rotating. This is the point where it becomes L by 2. This is L by 2, this is the point. So after this almost becomes vertical because this length is constant, right? This length is constant throughout the process. But now if I pull it further, this point, this submerged length changes. So if the submerged length changes, it cannot be in any more rotational equilibrium. Suppose this is phi, it cannot be in any rotational equilibrium because we got in the previous thing that h by sine theta is equal to L by 2. But if the L by 2, if it is more, it becomes vertical. It rotates and becomes vertical. At a point it becomes vertical. But after that, when this point also increases above the water level, it cannot be in any rotational equilibrium anymore. But what will be then? Will it accelerate? No, it will not accelerate because it's told that it just comes up slowly. So what will it be? It will then be a vertical equilibrium. It will be a translational equilibrium only. We don't have to think about anything else anymore. So we just in this case, so basically what the rod rotates, it rotates and becomes vertical. And after that, it just goes up like this. It has no rotation anymore because it rotates. There is sine theta, but this length is constant. Is L by 2. This cannot be negative, na? This there, but that the length has to be L by 2. So now I give now I just the next part because after this length is less than L by 2. Means sorry, this length is less than L by 2, then it will be just in a translational equilibrium. Now what will be the translational equilibrium? That will be T equal to mg minus the band force. Band force will be L minus h into m by L into 1 by gamma into g. This is self-explanatory. I have explained it before too. So this will become directly this. Now this is also not valid for eternal because h is limited because after h equal to L, then the buoyant force will not anymore work because everything is above the water level. So this will work only up to a level h equal to L. After then t equal to only mg because it will be in hanging and this is your t and this is and there is nothing here. So t is equal to mg after t equal to. So thank you guys. I hope you like this problem. I hope you like the solution. Is I like the problem and it is very high chance to come into the advanced because seeing the previous questions, I think they mainly focus on something you should analyze, something you just not to be based on just calculations because for that there is math. You can do calculation there, but for your analytical powers, they will give this type of problems. I hope you liked it. Please share this channel as much as possible. I'll solve problems and we'll crack J. You will crack J. Let's crack it. That's probably a big educational institution's tagline, but that's okay. That is a very good tagline. I like it.